Okay guys, so let's try this on an example. So before that, let's read the problem first. So the wooden bar consists of two segments. Okay? So each of length L. Okay, so pinakita dito. Two segments siya. So yung unang segment, which is a square bar, so non-circular siya. So pasok yung na-discuss natin earlier. So ito yung naka-fix dun sa iyong end, dun sa support. And then, between these two, meron na connect na circular rod. Okay, so which yung dimension niya, ang diameter niya is given as D. So each of length L, ayan, shown in the figure. So the cross-section of the other segment is a circular or diameter D. The working stress for the wood is, sulat natin. So ito should be tawa, T sub W is equals to 5 mega Pascal. And the shear modulus is 0.5 gigapascal. So shear modulus 0.5 gigapascal. Using length as 0.6, sabihin na natin 600 mm ha, para direction convert na siya. So 600 mm both kasi parehong L nga siya. And the diameter D as 50 mm, okay? So first, we need to determine the largest torque D that can be safely applied. And number 2, the corresponding angle of twist of the 4D bar. Okay, so guys, I think it's much better if we write first the available equation. So if we are going to recall the lecture part that we discussed earlier, so yan na lang natin to. Ano? So first, for the shearing stress, so this is applicable only for this segment, ha? This is a square bar or square rod. So the maximum shearing stress is given by the equation na T over C1 AB squared. T over C1 AB squared. Again, A is defined as greater than or equal B. But, as you can see in the figure, pareho kasi silang D. Therefore, A is just equals to D. Okay? So, since pareho lang naman sila, let's say na pangalanan na lang natin to as our D. Kasi yun naman yung given do sa problem, di ba? Or this equation can now be written as T all over C1. So, kung parehong D yan, D times D squared. So, this will become D cube. Okay lang ha. Kasi sabi ko nga, since pareho naman, yung A mo is just equals to sa B. So, inilat ko na lang siya as D. Okay? And since yung formula natin is AB squared, so, pag pinalitan mo ng D yan, yung A mo, pinalitan mo ng D, yung B, pinalitan mo ng D. So, ito yung magiging equation niya. Alright? And then next, for the theta. So, isulat rin natin yung equation niya. So, sinisilip ko kasi ito, bago lang din sa aking paningin. So, TL all over C sub 2 AB cube G. C sub 2 AB cube G. Again, ganun na rin. Gawin natin, simplify natin yung equation. So, ito is magiging TL all over C sub 2. And then A, so DD. So, ito is magiging D raised to 4, tama? Over G. Ayan. So, ito na yung mga equations natin. So, ito, for the shearing stress, ito yung magiging equation. And for the angular deformation, o angle of twist, TL all over C sub 2, D raised to 4, G. Ngayon, if this is the case, A is equals to B. So, kung pareho sila, therefore, yung value ng A over B mo will be just equals to 1. So, bakit natin hinanap yan? So, kailangan natin, guys, makita or mahanap kung ano yung value ng C1 and C sub 2 using the table discussed earlier. So, baba ko lang. Ayan. So, ano yung corresponding value kapag 1? Ito. So, ang C1 mo will be equals to 0.208. 0.208 And then for C2, so that will be equals lang sa 0.141. 0.141. Ayan. So now, pwede na natin ma-solve yung largest torque T. But since dalawang segment yan, isang circular and isang rectangular or square, meron tayong dalawang value ng torque na maukuha. Okay? So sige, siguro unahin muna natin yung for the segment. Since pareho rin silang wood, so we need to check both the circular and the rectangular segment using this maximum given stress for the wood or the working stress for the wood. Okay, so unahin natin yung sa circular. Again, ano nga yung formula natin for a circular shaft? So for the shearing stress, T max. So that is equals lang sa T R over J. So ako again, I preferred if ito na lang yung gagamitin since, ayun nga, sabi ko nga, medyo mahina tayo sa sauluhan. Ano? So para mas madali, ito na lang yung gagamitin natin. So if you're going to rewrite that, and we solve for the T, so the equation will be T is equals to the shearing stress max times J all over R. Okay? And then yung J again, so ano nga yung ano natin for a circular? Diba ang J again is the polar moment of inertia, which is equals lang yan sa Ix plus Iy. Okay, so for a circular moment of inertia with respect to the centroidal axis, so equals nga siya saan? Diba yan ay equals lang sa pi r to the 4th over 4. So yung Iy mo, ganun din, plus pi r to the 4th over 4. Okay? So, I think dito na lang natin siya isulat para at least hindi mas maano dito. So, pi, given yung iyong radius, again, binigay sa problem na 50 yung diameter, therefore ito is magiging 25. Tama? 24 raised to 4. So, since dalawa yan, pareho lang naman, i-multiply ko na lang ng 2. Okay? So, what will be the value of J? Open lang natin yung calculator. So, that will be pi times 25 raised to 4 divided by 4 and then times 2. So, ito yung sagot natin. Medyo malaki. So, ang gagawin ko, shift store alpha na lang. So, ang sagot nito is nakatago daw sa alpha. Pero kung babalikan again, ito yung value niya ha. 613.5923 times 10 to the 3 mm raised to 4. Okay? So, now, balik tayo dito. So, ano yung magiging torque natin? So, that will be, di pa pala A. So, that will be 5. So, ito is na mm raised to 4. Wala magiging problema yan. So, times A. Okay, so since doon natin tinago, all over the radius R na 25 or 50 over 2. So, what will be the answer here? So, answer times 5 and then divided by 25. So, that is 122.718.463. So, this is in, since megapascal, Newton per mm squared. So, this is Newton mm. Okay? So, hindi pa ito yung final answer kasi this is only applicable for the circular shaft. Ngayon, i-check natin siya considering this squared. And yung formula na gagamitin natin is this one. Okay? Eto. So, if you're going to solve 40, sige, isulat mo na ulit natin. Ito, ginawa ko lang maximum or working stress. Okay lang yan, pareho lang yan. T over C1 d cube. Or if you're going to solve 40, so that will be the shearing stress maximum times C1 times d cube. Alright, so ano nga yung shearing stress natin? So that is 5. And then yung C1, nakuha natin sa table as 0.208. And then yung D, that is 50 cube. Okay? So, pindutin na natin sa AlQ again. 5 times 0.208 and then times 50 cube. So, that is 130,000. Sakto. 130,000.0. So, this is in Newton, mm din. Okay. So, guys, between these two answers again, alin ba dyan yung consider natin for the largest torque T? Okay. Is it 130,000 or this 122,718 Newton mm? Okay, so agaya do sa mga naunang topic and yung principle na naituro ko sa inyo, guys. Ito kasing torque na to, pwede mo siya i-consider as force. Oh, no, sorry. This is a moment. Kasi ang unit niya nga is force times distance. And ito, pwede mo siyang i-consider as a force. Okay? So, therefore, when we're talking about a force, torque yan eh. Twisting moment, or it causes the rod to twist. So, kapag ganyan mga force ang pinag-uusapan, again, kapag ang pinag-uusapan or ang hinahanap is yung largest torque T, so, ang consider mo sagot is yung may pinakamaliit na value. So, for this, number 1, the correct answer for this is yung 122,718. Again, pwede mo naman siyang, i-check. So, pabalikin mo, So, again, ito yung limit na susundin mo. So, once na lumampas ka dito sa value na 5 megapascal for the shearing stress do sa wood or the working stress for the wood, mababiolate mo na yung rule kasi lumampas ka. It's either equal yan dyan or less than dyan sa value ng 5 for it to consider to be safe. Okay? So, once na nag-exceed ka dyan sa 5 megapascal, so therefore, yung system mo is mag-fail. It's either humiwalay yung isang portion do sa kabila. Ayan. So, those are the possible things na pwede mangyari if mag-exceed ka do sa allowable stress natin. Okay, so for number 1, guys, ito again yung correct answer for number 1. Okay, so for number 2, so what will be the corresponding angle of twist for the bar? So for number 2 naman, since connected sila and ang pinapahanap is yung total angle of twist, so ang mangyayari lang dito, again, di ba, pag circular rod, there's a separate formula for that. Di ba yun saan yung equal yan? TL all over JG for a circular rod. Ngayon, there's a separate or there's another formula naman kapag square or rectangular rod. So we will use this formula. So to get or to solve for the total angular deformation or angle of twist, so that will be, so gawin ko na lang to as theta 1 plus theta 2. Again, yung theta 1 is for the angular or angular deformation or angle of twist for this circular shaft. So that will be TL all over JG. And then yung isa para dito, which has a formula na ito. So plus TL all over C sub 2 na nakuha natin sa table, D4 raised to G. Okay? So, that is equals lang. So, again, TL, ang gagamitin natin T is yung 122,000. Tinago ko ba yung value nung So, ang gawin natin, guys, ay Ito. Ano ko lang ha, kasi medyo mahaba rin para hindi na natin pipindutin. So, alpha nga yun, 5A divided by. Ayan, 1222. Ayan, tama. Ship store, itago ko siya sa B. Para hindi na lang natin encode isa-isa. So, ugaliin nyo na rin to, para walang tapon doon sa mga natin. Ayan. So, ang gagawin ko dito, substitute lang natin. So, yung T nga, ginawa natin B times yung L, which is 600 over J. So, tinago ko siya sa A. Ayan, mas madali yung equation natin. So times G, which is 0.5, kaso naka-gigapascal siya. Again, yung conversion niya. So we have 1,000 megapascal in 1 gigapascal. Therefore, yung 0.5 gigapascal para maging megapascal, imumultiply natin ng 1,000 or that will be equals lang sa 0.5. So gawin ko na lang times 10 to the 3 ha. Or multiply it by 1,000. 0.5 times 1,000. Ganun lang din yan. And then next, plus, again, yung T is tinago natin sa beta. So B times 600. So titingnan nyo guys ha, hindi lagi siyang 600 kasi sinabi lang dito sa problem na pareho sila ng haba na 600. Pwede kasi mangyari dito, magkaiba to, ito 600, pagpalagay ng itong isang segment is 1,000. So kung ito ay 1,000, ang ilalagay mo dun sa merong C2 is 1,000. Okay? Kasi again, magkaiba yung formula nila ng angle of twist or angular deformation. So times C2, 0.141. And then D raised to 4. Again, what is D? So 50 raised to 4. And then times G or 0.5 times 10 to the 3. Alright. So guys, pindutin lang po ulit na sa AlQ. So check ko lang ulit yung tago kung tama yung beta. Okay. So beta times, sorry. So beta times 600 divided by alpha and then divided by 0.5 times 10 to the 3. And then plus our beta, so times 600, then divided by, i-quantify ko na, 0.141, so times 50 raised to 4, and then times 0.5 times 10 to the 3. So most probably maliit lang yung sagot. Ayan. Kaso nga ito is naka-radian. So para maging degrees yan, sige, sulat muna natin. 0.4071. 0.71 radian. So para maging degrees, just multiply it by 180 over pi. Ito may pi rad talaga yan eh. So times 180 divided by pi. So, ayun, 23 degrees. 23.3255. 325. Laki ah. Kasi wood lang yan eh. Okay. So, it's either of these two. I will accept it. Pero, para uniform na lang tayo. Naka-degrees na lang. Kasi nga angle of twist eh. 3255. Alright guys, again, I'll give you 3 minutes to copy the solution. So you may start copying. Alright guys, let's proceed with the next problem. So again, para dito sa last video, ito yung mga random problems or ayun nga, pipili ako ng problems under this topic na sasagutan natin na para meron kayong more example na maging basis nyo while studying or solving the problem set on your workbook. Okay, so yun lang.